Now we are going to learn about the new topic called pressure, kinetic and potential energy of a liquid. When a liquid flows through a pipe, that liquid it may possess kinetic energy and also potential energy. Sometimes it may have pressure energy. So there are three kind of energies may be possessed by a liquid. Let's see the three kind of energies one by one. Here look at the first diagram in which the liquid that flows through a pipe with a velocity v, its mass can be taken as m. So what is the basic fundamental formula to calculate the kinetic energy? Kinetic energy of the liquid can be written as half mv square. Are you clear? This is the fundamental formula to calculate the kinetic energy of any moving bodies. Here liquid flows. The liquid's kinetic energy can be measured by using this formula. Understood? Now we have to calculate two more things. One is called kinetic energy per unit volume and kinetic energy per unit mass. These two quantities are essential while learning about the Bernoulli's theorem. Now I am going to calculate the kinetic energy per unit mass. Are you clear? Kinetic energy per unit mass. How to calculate? Look at that. Here, in the first step, I have calculated the total kinetic energy of the entire liquid. Now I am calculating the kinetic energy which is stored up in the unit mass. So what I have to do? The same formula must be written. Half mv square to be written divided by m. Cancel both m's. So finally you are getting v square divided by 2. So this is the expression that one gives you the kinetic energy which is stored up in a unit mass of the liquid. Are you clear? The next one is kinetic energy per unit volume. Are you clear? Kinetic energy per unit volume. How to calculate? The same formula, half mv square, that is the kinetic energy of the entire liquid, per unit volume means capital V must be written. Capital V is the must one. Understood? So in the next step we can write half that mass and volume both can be written together and that should be written within the bracket, and V square can be written. Mass per volume, that one gives you mass per volume is nothing but density. Are you clear? Mass per volume is density. In the next step we can write half mass per volume can be written as density. Its symbol is rho v square. So this is the expression that gives you, what is this? Kinetic energy per unit volume. So this is the expression. Understood? So we have calculated the kinetic energy part. Is it clear? Next we are going to learn two more kind of energies. The next one is about potential energy. Here when liquid flows through a pipe, and if the pipe is kept at a certain height from the ground level, by that time what will happen? The liquid will possess potential energy also. Due to its position from the ground level, it will gain some amount of energy, that is called potential energy. How to calculate the potential energy? What is the general formula? Potential energy of any object from ground level is, what is the formula? M into G into H. What is H? The height at which that liquid flows through the pipe. What is M? Mass of the liquid. As we have calculated earlier here also we have to calculate potential energy stored in unit mass. Potential energy per unit mass must be calculated. So what is the formula? M into G into H divided by M. M can be cancelled. So the formula is GH. So this expression that gives you potential energy stored in unit mass. The next one is potential energy per unit volume to be calculated. Therefore I have written PE divided by V. Are you clear? PE divided by V. Substitute now mg H divided by capital V must be written. Already I have told mass per volume is nothing but density. Therefore mass per volume can be replaced. mv, both of them can be written together and it can be written within the bracket. GH must be written. Mass per volume can be written as rho. Are you clear? Mass per volume can be written as rho. GH. This is the expression that gives you potential energy per unit volume. This is called potential energy per unit mass, GH. This is called potential energy per unit volume. So this much amount of energy is stored in unit volume. This much amount of potential energy is stored in unit mass of the liquid. So here two expressions are derived. Here also we have derived two expressions. Make a note. This is a fundamental expression. Are you clear? Next we are going to calculate one more kind of energy called pressure energy. Here, to understand the pressure energy, I have drawn a diagram. Here let us imagine a container in which water or any other liquid is filled up. Here at the bottom you have to assume a piston-like arrangement. Are you clear? So you have to apply the pressure from externally. If you apply the pressure from externally, due to the application of pressure, some amount of energy will be stored up in the liquid. Let us imagine the cross-sectional area of the piston is A. If the piston, if it is moved up to certain distance D, is it clear? It is moved from this position to this position. If it is moved from this position to this position, that displacement occurs, no, that can be taken as D. Understood? So due to the application of that pressure, you are doing some work done. That work done will be stored up here in the form of, what is this? Work done, that one will be stored up in the form of energy. The work is done by the pressure. Are you clear? You are pushing the piston towards inward direction. The work is done by the pressure. The work done, what is done by the pressure, will be stored up in the form of pressure energy. So first what we have to calculate? What is the formula? Work is nothing but pressure energy. Are you clear? Work done is nothing but, first I will write the fundamental formula. Work done on the liquid is nothing but pressure energy. This is the formula. Understood? So how to calculate the work done? Work done can be calculated by force into displacement. Are you clear? Work done can be calculated by force into displacement, that gives you work done. Are you clear? So how to calculate the force? What is the fundamental formula? Pressure is equal to force per area. Are you clear? Some amount of force is acting on the area. So how to calculate the force? Force is equal to pressure into area. So in the next step we can write pressure into area into D. So in that format we can write. Understood? So what is the next step? Here area of cross section is A. The distance travelled by the piston from here to there is D. If both are combined, if A into D is multiplied, you will get volume of the portion. That volume of the portion can be written as capital V. Therefore pressure energy can be measured by the formula. Is it clear? Pressure into volume. Is it clear? Pressure into volume. That one gives you the pressure energy. Make a note. Are you clear? So this much amount of energy is stored up within the liquid due to the external pressure. Understood? Here this is the formula and it can be written as, it can be symbolized as EP. What is EP? EP is called pressure energy. Understood? This is potential energy, this is kinetic energy, this is called pressure energy. As we have calculated earlier, here also we have to calculate pressure energy per unit mass. Pressure energy per unit mass must be calculated. How to calculate? Pressure energy expression is P into V divided by M. So this is the formula. Understood? Now P into, here volume divided by mass is there. Mass per volume is density, but volume per mass is there. Volume per mass can be written as capital P, pressure, into volume per mass is 1 by rho. So what is the formula? Pressure energy per unit mass can be written as, what is this? P into 1 by rho. So the final expression is P divided by rho is the formula to calculate which factor? Pressure energy per unit mass. Understood? Now we have to calculate one more factor called, what is this? Pressure energy per unit volume. How to calculate? Pressure energy per unit volume, capital V must be written. What is the expression for this one? P into V divided by V. Understood? Now V can be cancelled. Finally, we will calculate P. So the pressure energy per unit volume can be written as pressure energy per unit volume can be written as V cancelled, no? Finally, you are getting P. So this is the expression that gives you pressure energy per unit volume. Are you clear? So again, I would like to recall there are three kind of energies may be possessed by the liquid. That depends on the conditions. When the liquid flows through a pipe, the liquid will have kinetic energy. When the liquid, if it is kept at certain height, it's clear that liquid will possess potential energy. When the liquid is pressurized, within the liquid, pressure energy will be stored up. Are you clear? In each case, you have to calculate kinetic energy per unit volume, kinetic energy per unit mass. Are you clear? Potential energy per unit mass, potential energy per unit volume, pressure energy per unit mass, pressure energy per unit volume. In each case, these factors must be calculated because all the factors are very essential to learn about which one? Bernoulli's theorem. Are you clear? So, in the next step, we are going to learn about Bernoulli's theorem. Their equation of continuity and the three kind of energies which are possessed by the liquid all are essential to learn thoroughly about Bernoulli's theorem. Thank you.